Welcome to week 2, Data Science Essentials. This week, on day 1, we'll cover Introduction to NumPy for Numerical Computing, followed by day 2, where we will be looking at Advanced NumPy Operations. Day 3 will cover Introduction to Pandas for Data Manipulation. Day 4, we will be looking at Data Cleaning and Preparation with Pandas. Day 5 will be Data Aggregation and Grouping in Pandas. Day 6 will be Data Visualization with Matplotlib and Seaborn, followed by Day 7, where we will be looking at an Exploratory Data Analysis or EDA project. So let's get started with week. Welcome to day 1 of week 2, where we'll be going over Introduction to NumPy for Numerical Computing. Today's topic, first, we will be looking at understanding the role of NumPy in data science and AI. What is NumPy? NumPy, or numerical Python, is a foundational library in Python for numerical computations. It provides a fast, efficient way to perform operations on large datasets using arrays and supports advanced mathematical function. Now, why use NumPy in AI? First, because of the performance. NumPy arrays are more efficient than Python lists. Ease of use. Built-in operations for mathematical and linear algebra functions helps you easily implement a lot of different mathematical and linear algebra functions. Integration. Works seamlessly with libraries like Pandas, Matplotlib, TensorFlow, and PyTorch. That's why we're using NumPy in AI. Next, creating and manipulating NumPy arrays. First, let's look at how to import our NumPy library. So to do that, you say import NumPy as NP. So I'm going to start a new file, Python file, save it inside our week 2 in this particular case, day 1. I'm going to create a file called as day 1 NumPy basics.py. Now here, to import NumPy, as I mentioned, import NumPy as NP. So I'm going to use the alias NP for this. Next, creating arrays. Now there's different ways of creating arrays. One is from a list. So from a list, how do we create an array? So let's look at an example here. Create an array. I can say np.array and give it the list that you want to do. Give 1, 2, 3, 4. And if I print this array, I will see, I'll say Python day 1, and there you go, 1, 2, 3, 4. So from a list, we have created a NumPy array. Next is using built-in functions. Now there's some built-in functions. For example, we have, let's create a variable zeros, np dot zeros, and I am going to say 3, 3. What this does is it will create a 3 by 3 matrix of zeros. We can print that just to check how it looks like. There you go, a 3 by 3 array of zeros. This is the first one, that's why it was still showing, but I'm going to comment these out. Next, ones. I am going to create np.ones. You probably already know what it does, but I'm going to say 2 by 4. So this will create a 2 by 4 matrix of ones. If I print it, and there you go, 2 by 4 matrix of ones. Next one, I'm going to say range array equal to np dot range. What this does is it returns an evenly spaced values within a given interval. So for example, I want to get 1 to 10 numbers, but an interval of 2. So if I do this, I will get 1, 3, 5, 7, 9. So what it did was it went to 1 to 10 with evenly spacing of 2. So the interval of 2. So 1, it skipped 1, 2, then gave me 3, skipped 1, 5, skipped 1, 7. So every 2 it skipped and went to the next one. So 1 and skipped 2, went to 3, skipped 4, went to 5. So that's what this does. If I give it a spacing of 3, I get 1, 4, and 7. 1, skipped 2 and 3, fourth one, skipped 5 and 6, third one is 7 then. So that's what it gives me. If I give a bigger number, there you go, 1, skips 2, 4, skips 2, 7, keeps on going all the way till 97. This is how it can work. Next one that I want to show is linspace. So I can just say linspace underscore array equal to np dot linspace 0, 1, 5. So what linspace does is it returns evenly spaced numbers over a specified interval. So if I say that I want from 0 to 1 with the interval of 5 inside that, so what it will give me is 0, 0, 0.25, 0.5. So it gives an interval of 5 and gives me that inside in between the two numbers. So let's look at this. So this is 0, 0.25, 0.5, 0.75, 1. So these are 1, 2, 3, 4, 5 different numbers evenly spaced in between this. If I do this 1 to 10 and run it, it will say 0, 2.5, 5, 7.5, 10 evenly spaced. If I say 4, then it will probably give me whole numbers. So no, 0 is 3.33, 6.66, 10 point. So for 3, it will give me 0, 5, and 10. So evenly spaced with whole numbers in there. Next, let's look at manipulating arrays. So we can do a bunch of different things like changing the shape of an array, and we can also add dimensions to an array. So let's look at those examples. I'm going to go back to the same one and get rid of everything. I'm going to clear this out too. And here I'm going to start first array equal to, I have removed the import statement too. So I'm going to say array equal to np dot array. So if I want to create an array from a list, we already saw how to do that. 1, 2, 3, 4, 5, and let's give 6 this time. And then I want to reshape this array. I'm going to call the reshaped array equal to array dot reshape, and say that I want to reshape into 2 by 3 matrix. Let's print it out. So instead of one single dimension, it's going to have 2 by 3 matrix for me. So if I run this, I have 1, 2, 3, 4, 5, 6. So it took and reshaped that. I can also do 3 by 3, and it will give me an error because I don't have 3 by 3 elements here. I have 2 by 3, or I have 3 by 2 since I have 6 elements. There you go, 1, 2, 3, 4, 5, 6. So I can give any of those combinations. If I add 7, 8, and 9, and now do 3 by 3, it will give me 1, 2, 3, 4, 5, 6, 7, 8, 9. I can create whatever multiples that is available based on these 9 elements and create a reshaped array or different matrix. Next thing is to adding dimensions. Now that I can do by saying np dot array. Let's create an array with 1, 2, 3. So this array, let me comment out these things. Now when I have that array, I'll say expanded another object array. So this will add dimensions to it when I say np dot new axis. So let's look at it, how it adds a new dimension to this. Expanded, and you see 1, 2, 3 has added new axis for each and every element. Since I've not given a dimension here, creates 3 different dimensions for each and every element in here. So this is how you can manipulate a basic arrays and create, like, reshape them or add dimensions to them. Next, let's look at some basic operations on arrays. So we'll look at element wise operations and we'll look at mathematical operations. Let's jump in here. I'm going to create an array a equal to np dot array, and inside that I'll add 3 elements, 1, 2, and 3. And then I'll create another array, call it as b np dot array. In this particular case, I'm going to give numbers 4, 5, and 6. So I have these arrays. Now To do element wise operations, let's say I want to add these two arrays, I can do print a plus b. That's a good thing that you can do with numpy arrays, where you can add. This will give you an output of, based on this addition, 4 plus 1 5, 5 plus 2 7, and 6 plus 3 9. If I want to do, let's say, multiplication of these arrays, a times b, it will give me 4 times 1 4, 5 times 2 10, 6 times 3 18. I can also do division, a divided by b. This will give me 0.25 for this, 5 divided by 0.4, and 3 divided by 6 is 0.5. So that's what it will give me. Let's go ahead and run this. Let's clear it out first and run it on a clear board. So I have 5, 7, and 9 for addition. Multiplication, I have 4, 10, and 18. And for division, I have 0.25, 0.4, and 0.5 for 1 divided by 4, 2 divided by 5, and 3 divided by 6 respectively. Next, let's look at some mathematical operations. So I'm going to say array equal to np dot array, and I'll create 1 comma 2 comma 3. Could have just used the previous one, but that's fine. And here I am going to do a square root. So I can say np dot square root of the array. So you can always make it a better example. I can say 4, 16, 25. Let's see how it look like. And here it is 2, 4, and 5. So it took square root of this and give me a new list with square root items in there. I can do print np dot sum of array. I am sure you got what it does. I'm going to clear this out, and we see 45, which is sum of all these three numbers. Next, I can do a mean, np dot mean of all the numbers in an array. Clear, run it, and mean is 15 for these three. Next, I can do a max also. I can just copy this and say max of this particular array. Clear, run it, and the max is 25. As you can see, 4, 16, and 25. 25 is the max. But if you have a bigger array or list of item, you can kind of find the max in that particular list. Next, let's look at array indexing, slicing, and reshaping. So first, let's look at indexing. Indexing is something similar where you can get an element for a particular index. Then we'll look at slicing, where you can slice an array into a smaller array, which we have done in list before in Python last week. And then reshaping, where we can reshape a particular array, which we have seen earlier today. But let's look at how this can be done again. So first, as I mentioned, indexing, array equal to np dot array. I'm going to create an array and probably try to reuse this one. 10 comma 20 comma 30 comma 40 comma 50. So 10 to 50. Next, I want to print a particular object in this array. So I can just say array at item number 2. It will print me 30 because this is index is 0, 1, and 2. Now, if I similarly in what we did in list, you can also use negative numbers. For example, -1 will give me the last element because this is the 0th element. So if you go behind, this is -1, -2. So that's how this works. Let's check it out. So it should give me 30 and 50, for 30 for index 2 and 50 for index -1. Next, let's look at slicing. So I can do slicing similar to what we did before, where you can say that I want items from 1 to 4. In this case, I will get items 20, 30, and 40 because 1 is this, 30, 2, 3, and doesn't include the last element. So index 1 to 4 minus excluding the last element. And similarly, I can do array comma 3. So what this does is it will give me all the numbers before until 3. So 0, 1, 0, 1, 2, and it will not give me the third element, of course, because it will give me 10, 20, and 30. So starting from the start all the way up till 3. Similarly, you can do the other way too, where you say that you want everything starting from 3. So that will give you 40 and 50. 0, 1, 2, 3, and 4. Next is reshaping, which we have seen earlier, where I can say reshaped array equal to array dot reshape. I have 1, 2, 3, 4, 5 elements. Put 60 just so that I can do a reshape of in this particular case 3 by 2 by 3 and print reshaped. So see, this saw this earlier. So it reshaped the array into 2 by 3 from 1 by 6. It converted into 2 by 3. So that's our reshaping. Next, based on whatever we learned, let's do our hands-on exercises. Our first exercise is to generate an array for basic mathematical operations. Here, the objective is to practice creating arrays and performing operations. The things that I'll follow here is first I'll create two arrays of size 5 using np.range and then perform addition, subtraction, multiplication, and division on those. So let's get started. It's pretty straightforward. I am going to call it day1 underscore exercise 1 dot py. Here, as I mentioned, I'm going to create two arrays, np dot range. First, of course, remember to import numpy as np and then range 1 comma 6. So this will create an array of 1 2 3 4 5. I'm going to create another array, np dot range and this one I want to create, let's say 6 comma 11. So this will cause 6 7 8 9 10. That's what it's going to create. So I have two arrays. Now first let's do a addition operation, which is a plus b. What I'll do a subtraction, multiplication, division. So I'm going to say sub multiplication and division, multiplication, subtraction. Now if I run this, let's clear this out. I'll say Python name is day1 underscore ex1, and there you go. We have the addition of the two arrays which had, if you want to see how they look like before I print them, I can say print a and print b. Go ahead, clear it out and run it again. So a and b, so addition 6 plus 1 7. I can also look at the last one, 10 plus 1 15. Subtraction of those, multiplication of it, and division of those two arrays that I have created. So this kind of completes our exercise 1, where we generated an array for basic mathematical operation. Our exercise 2 is to create a 3 by 3 matrix and perform operations. So the objective here is to work with the multi-dimensional arrays and perform basic operations. So we'll first create a 3 by 3 matrix using np.array. Then we will calculate its transpose using .t and perform element-wise addition and multiplication with another matrix. So let's try this out. So first, let's create a file, call it day1 underscore ex2.py. I'm going to create a matrix equal to np dot array, and since it's a matrix of let's say 3 by 3, I said, so I'll create first one 1 2 3 comma 4 5 6 comma 7 8 9. So I have this matrix of 3 by 3 array created. Of course, I need to import numpy as np. Next, I want to print. Let's print this original matrix so we can differentiate, comma matrix. I'll put it in the next line, so slash n. Next, to do the transpose operation. To do this, what we'll do is we'll create a transpose object, a variable, and say matrix that we created dot t. That's all you need to do. Let's print the transpose of this slash n comma transpose. Just try it out, clear it out. Python, this is day1 underscore ex2.py. And there you go, there's our original matrix. And here is a transpose where you can see 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9, 7, 8, 9 in this particular angle. So it's created a transpose of this original matrix. If you don't know what a transpose is, it's pretty much reflecting the rows and switching the columns and rows here. 1 by 1 was changed to 1 by 1. 1 by 2 was changed to 2 by 1. So that's why 2 is here. So it kind of switches the rows and columns. Next is let's do element wise operations. So let's create another matrix. I'll call it, for simplicity, another matrix np dot array, and this time I'll create 9, 8, 7 comma. I can even use the transpose to do the same operations, but it's more fun to create a completely opposite side matrix 987 654 321. So I have another matrix. I'm going to say print. Now this first one is element wise addition slash n, and I want to display matrix plus another matrix. I'll also do multiplication, which is much more complicated in matrix, times, and clear this out. Let's run it out. So we have the transpose, and then here we have the addition. Because it's all opposite numbers, it should give you a matrix of tens. And then for multiplication, we have this output here, which is multiplications of 9 by times 1 is 9, 8 times 2 is 16, 7 times 3 is 21. So that's what we got element wise arithmetic here. So I hope you were able to follow along and build both these exercises, exercise 1 and 2. If you had any issues or problems, let me know in the comments and I'll get back to you. And for some additional practice, you can create a 4 by 4 matrix and calculate the sum of its rows and columns. Try that out. Next, you can write a program to normalize an array, which means scaling the values between 0 and 1. And then finally, try to generate a random array and find the minimum and maximum values. And do these using NP or NumPy library and not just the basic list. So it's more fun. So in summary, on day 1 of week 2, we learned the basics of numerical computing with NumPy, focusing on creating, manipulating, and performing operations on array. The hands-on exercise hopefully will ensure practical understanding of mathematical and array operations. If you had any questions or problems, let me know and I'll get back to you. Day 2, Advanced NumPy operation. We looked at NumPy yesterday, but today we're going to look at some of the advanced NumPy operations that exist. So first, we are going to cover broadcasting in NumPy. Now, what is broadcasting? Broadcasting allows NumPy to perform arithmetic operations on arrays of different shapes. Smaller arrays are automatically expanded to match the shape of larger arrays. Some of the rules of broadcasting include dimensions are aligned from the right, and a dimension is compatible if it matches the other array's dimension. One of the dimension is 1. So let's look at some examples for this. So first, I'm going to import NumPy, and then we'll do some array and scalar broadcasting, and then look at array broadcasting in detail. So for this, I'm going to create a new file, call it a Python file, save it under my week 2, day 2. I'll call it day 2 underscore samples, and start with importing NumPy as NP. Next, let's do some, I'll add a comment here, array and scalar broadcasting. How does this work? So first I'll say array equal to np dot array. So I'll create an array from a list 1, 2, and 3. So this is my array. Now I'm going to say print array plus 10. So this what it does is it adds 10 to each and every element in here. If you want to see an example, I'm going to say clear ls, and I'm going to say, oh, I said day samples instead of day 2 samples, but that's fine. I'm going to say python day samples. I have 11, 12, and 13. So 10 was added to every single element. So it's kind of broadcasting the number to each and every element, and it added there. So in a scalar array. So let's look at more on the array broadcasting. So I have a matrix equal to np dot array, and this one I'll create a 2 by 3 matrix, 1 comma 2 comma 3, and the next element in here I'll add 4 comma 5 comma 6. Straightforward one. So this will create me a matrix 2 by 3, which is 1 to 3, and 4 by 4 5 6. I'll create a vector np dot array, call it 1 comma 0 comma 1. Okay, so there you go, that's our vector. Now I am going to say print matrix plus vector. So the output for this will be based on the values that we have here. 101, it will give me 2 2 4, and below it will be 5 5 7, because it kind of takes this vector and adds it properly to each line of the matrix. Let's look at the output. And we have 2 to 4, because 1 plus 1 2, 2 plus 0 2, and then 3 plus 1 4. That's what we have. Then next line 4 plus 1 5, 5 plus 0 5, and 6 plus 1 7. So this is how array broadcasting works, where you take a vector here, a single array, and then I am broadcasting it to the entire matrix here. Next that we're going to look at is aggregation functions. Now aggregation functions compute summary statistics for arrays. So it's pretty helpful in AI world. So let's look at some of the common functions that are available in the aggregation functions. So I'm going to go here. I am going to remove everything, create an array, np dot array. I'll create a matrix here. It will be a matrix of, oops, need to fix this, okay, matrix of 1 2 and 3 comma 4 5 and 6. So I have this matrix here which is 2 by 3. Next let's look at some of the functions. First I want to do the total sum of all elements, so I'm going to call it sum, and I can use np dot sum. This is the function that you can use. This will give you the total sum of all the elements in this matrix up here. I can say print, I can say what is the mean of this particular matrix that we have. You can say np dot mean and pass the array to it. I can also get the max, similar way, max comma np dot max and pass the array to it. Similarly, I'm going to just copy paste this. I can get max, so I can get min. Say min, there you go. Next I want to get the spread of the data. How is the standard deviation? Standard deviation. For that, I'll just call the function std and pass the array to it. I can, what else can I do? Oops, sorry. Next, I can get sum along the rows. So sum per row. So that I can say sum along rows. For that, I can say np dot sum, and then I give the array, and I'll say access equal to 1. So it will take one single access, so it will give you per row. Same thing you can do for, oops, column, where you can, I'll say columns, np dot sum, pass the array, and access is 0. So one access is for the row, and for column access is equal to 0. So I do this, go back here, clear it out, let's run it. and you'll see sum is 21. If you add this 6 plus 5 plus 4, 3 to 1 is 21. Mean is 3.5, max is 6, minimum is 1, standard deviation is 1.7078, sum along the rows is 6, 15, 6 and 15, 3, 4, 5, 6, and 6 plus 5 plus 4 is 15. Sum along the columns is 1 plus 4 is 5, 7 plus 5, 7, 2 plus 5 is 7, and 3 plus 6 is 9. So that's how you can use the aggregation functions that are available. Next, let's look at Boolean indexing and filtering. Now, what is Boolean indexing? We use Boolean arrays or conditions to filter elements from an array. So let's look at some examples of Boolean indexing. What I'm going to do here is I am going to get rid of everything. I will create an array of a single axis array 1, 2, 3, 4, 5, and 6. So I have this array available. Next, I am going to filter all the even numbers. So to that, I can say evens array mod. I can also use mod operator equal to 0. What this will give me, it will print 2, 4, and 6. So this kind of filters even numbers. Say print evens comma evens. So you can check that out. Next is modifying the elements based on a particular condition. So for example, I can say array is greater than 3 equal to 0. So in this case, if the values are greater than 0, it will make sure that it will change that array values into 0. So I'll say modified array is array. Let's output this and check it out. So I have an array, again, let's clear it out. I have an array 1, 2, 3, 4, 5, 6. So to get the evens 2, 4, and 6, I've created this array. So this is more of a filtering option here. And then to modify elements based on a condition, if you see this 1, 2, 3, 0, 0, 0. So if array value is greater than 3 inside an array item, it will change those values into 0. So this is kind of very helpful when you work with data sets and you want to change values, especially when you are creating models or training models. Next, let's look at random number generation and setting seeds. We already did something random number generation in Python. Now let's see how we can do this using NumPy. So first, for random number generation, NumPy provides the np.random module for generating random numbers. Let's look at some of the common functions for it. So go back to this, get rid of everything. And I am going to first generate random numbers. So I am going to create a random array equal to np.random.rand. That's what we use, 3, 3. So this will create a random array for us, and the uniform distribution of 0, 1. So if I print this, you can see how this looks like. I'm going to say random array. I'll move the array to the next line so it's more clear. I'm going to call it random array. Let's go back, clear it out, and run this, and you see you have a random array of 3 by 3 which has random numbers with a uniform distribution from 0 to 1. Next, I want to generate integers instead of the numbers that we've created. So I'm going to call it random integers equal to np dot random dot rand. It's very similar until here, except it's rand int, say 0, 10, size of 2 by 3. So this one, as it says here, that it will return you an array, a matrix of 2 by 3 with numbers from 0 to 10, which are integers. So if I want to print this, I can print saying random integers /n, and that is my random, not array, that is my previous one, random integers. Let's go ahead, clear this out. So now we'll have two different, first for the random array, and then next is random integers. If I run it again, if you see, every single time it will give me different numbers and integers, array and integers, based on what it generates. Next thing that I want to talk about is setting random seeds. Now this ensures reproducibility by fixing the random sequence. Before, what happened was every time I run it, I was getting different numbers every single time. So what I can do here is I can say np dot random dot seed. I like my favorite number 42, and then now when I use the random numbers, output will always be same. So if I go back, clear, run it, no matter how many times I run, the values will be same because I've set a particular seed. And this is very helpful in some of the models where we are training the data set and picking a particular data set for training, and we want to make sure that every time we run that training set, it uses the same training set and testing sets for our models. So that this is very important to know about setting the seeds. Now that we have understood more about advanced NumPy, let's get into some hands-on exercises. Our first exercise is broadcasting operations. We've already done this, but the objective here is to perform operations on arrays of different shapes using broadcasting. So first we'll create a 3 by 3 matrix, and then we'll add a 1 by 3 vector to the matrix, and then we'll multiply the matrix by a scalar. So let's get started. Create a new file, save it as day2 underscore exercise 1.py. Now here, let's create a matrix equal to, okay, I need to import numpy as np, and then np dot array. Let's create this array of, as I mentioned, 3 by 3 matrix. So that I can do by first saying 1, 2, and 3, comma, next one I'll say 4, 5, and 6. The next matrix, it's very easy to guess what I'm going to do, 7, 8, 9. Perfect. I'm going to create a vector which is 1 by 3 array, np dot array, and here the vector I'll give it, this time I'll say 1, 0, and -1. Let's bring some negativity in the vector. Now broadcasting addition, we've seen that. I'm going to say result addition equal to matrix plus vector. So this will give me addition. So let's print it out just so we can see the results. Of course, I like to keep it clean, the code. So addition is common result add. Next, I want to broadcast a scalar multiplication. To do that, let's say result underscore multiplication equal to matrix times 2. Print multiplication, and here I'm going to say result mul. Make sure that it's on the next line for both of them, so it's cleaner result. And now our results should be based on addition of these two. So let's look at it, clear it out, run the code called as python day2 and .ex1. So there you go, that's our addition first, where we took this 1, 2, 3, 1, 0, -1, so that's why 2, 2, 2, 4, 5, 6, 1, 0, -1, so that's why 5, 5, 5, and increment same, decrement, and it was 8, 8, 8 here. Now multiplication for my matrix, which is this array, I multiplied by 2. That's why every single number 2, 4, 6, 8, 10, 12, 14, 16, 18 is twice what these values were initially. So that's our exercise 1, where we did the broadcasting operations again. Our second exercise is to generate and filter a random data set. We already did this, but again, this is an exercise that you should probably follow along. Here, the objective is to generate a random data set, filter elements based on conditions, and calculate the summary statistics. So we will create a 5 by 5 matrix of random integers between 1 and 50. You probably know how to do that, but again, we'll practice. Filter values greater than 25 and replace them with 0. We saw that, but we'll do that again. And calculate and print the sum, mean, and standard deviation of the modified matrix. Interesting enough? So let's go ahead and start it. Let me clear this out. I am going to create another one, save it as exercise 2, And here, first thing is import numpy as np. Next step is generate the random data set. So I am going to say data set equal to np dot random dot rand int. As I mentioned, I want a random integers array. And to this, I am going to say, and so it's 1 to 50. So I'm going to say 1 comma 51, and then size equal to 5 by 5 matrix. That's what I wanted to create. So this will give me a matrix of 5 by 5 of random integers between 1 and 50. Our next step is to print this so we can look at the differences. Original slash n comma data set. So we display the data set out. Next step, as I mentioned, filter the values greater than 25 and replace them by 0. So first, let me add comments here so we know what we are. Generate random data set. Next I mentioned was we will try to do filter values greater than 25 and replace with 0. And finally, we will calculate summary stats, which are we'll do the sum, mean, and standard deviation. So now to filter part, data set greater than data set where values of data set are greater than 25, I want to replace them by 0. As simple as that. We'll print this modified data set slash n comma data set. So it replaces the existing data set with the new data set. Now calculating the summary statistics of the new data set that we have. Let's say print sum of everything should be np dot sum of that entire data set. Next I want to, as I mentioned, I want to do mean, and next I want to do the standard deviation. Now mean was mean and standard deviation was HTD. So I have this. Let's go ahead and print it out and look if it looks any good. You can, I've not set the seed here. You can set the seed so every time the output is same, but I'm going to run it just one. So I'm going to say python day2 dot ex underscore ex2 dot py. And here is our original matrix 21 4. It has some numbers which are about 25. So those are, for example, this 40 is set to 0, this 34 is set to 0. So this is the modified data set with values restricting up to 25. The sum of this entire data set is 182. I'm not going to do addition manually. I trust the system. The mean is 7.28 and the standard deviation is 7.78. Pretty good compared as since I were going from 1 to 25 in this particular case, and we have reduced all the higher numbers to 0. So there is much more flexibility towards the lower numbers, and that's why the standard deviation and mean are more inclined to the lesser numbers. If I don't do this here, it will be much more higher. If you look at it, 584 is the sum, mean is 23, and standard deviation is 13 because we have more numbers towards the higher end. So I'll save this. I'm going to go back. Now let's talk about the next step. So we have some additional practice for you. You can create a 3D random array and compute statistics along specific axis. We did that previously where we specified axis equal to 0 or 1 depending on if you want to do column or row. Then you can write a program to generate a data set of random floats and normalize the values between 0 and 1. We did something like that. Some examples we have so you know where you're headed. And finally, implement conditional replacement to create a binary mask for values above a threshold. We did that in our exercises, so I hope that is helpful. If you have any problems or questions or need help on these, let me know. To summarize, today we dived into advanced NumPy operations, including broadcasting, we looked at aggregation, we did filtering and random number generation. Now, these concepts are foundational, as I mentioned, for efficient numerical computation in AI and data science workflows. It's very helpful, especially for training a model and testing those models with data. So, let me know if you want any more explanation on these or had any problems or questions. I will always get back to you. Day 3, Introduction to Pandas for Data Manipulation. We already completed NumPy and some advanced NumPy. Now let's look at the second favorite library, which is Pandas. First, we're going to look at Introduction to Pandas Data Structure, where we're going to talk about what is Pandas. Pandas is a powerful Python library for data manipulation and analysis. It provides an easy to use data structure, which is series and data frames. Let's look at those pandas data structures. First, series. Series is a one-dimensional labeled array capable of holding data of any type. And we have data frame. Data frame is a two-dimensional labeled data structure like a table. Let's look at the syntax for both of these. I'm going to go ahead and create a new file, Python file, save it. On my day 3, I'll call it day 3 underscore samples. Let's start with importing pandas. So to import, you say import pandas as pd is what alias will use, s equal to pd dot series, and to this I'll pass 10 comma 20 comma 30, a list of 3 items, which is 10, 20, 30, and I'm going to say index equal to a, b, and c. So now if I print this series s, how does it look like? So this will create kind of like a dictionary where each one of these is indexed at a particular point. So it kind of converts, you can think of it as a list into a dictionary. So let's go ahead and run this. I'm going to go ahead here. I'm in week 2, day 3. Perfect. Say Python day 3. There you go. And there you go. Our series A is 10, B is 20, C is 30. Perfect. So that's how a series works. A one-dimensional labeled array capable of holding data of any type in this particular case. The data in this particular type, if you'll see, is integer 64. It also specifies that. Next, as I mentioned, data frame, which is a two-dimensional labeled data structure like a table. So for that, I am going to say data equal to, I'm going to create a dictionary of name is, create a list inside there, names actually, Alice and Bob, and I'll create another key, age, and this age is a list of numbers, which is the age is 25 and 30. Now I can say df equal to pd dot data frame. This is how you create a data frame, data, and print df. I'm going to comment this out because we already saw how the series looks like, but how does a data frame look like? So I'm going to clear this out, run it, and here, there you go. We have 0 and 1 row. We have name Alice and Bob, age is 25 and 30. So it kind of creates a two-dimensional label data structure, which looks like a table. Next, let's look at loading data from CSV, Excel, and other sources. The kind of Pandas is used for that quite a lot, and it automatically converts them into data frames. So first, common data loading methods is, first we can look at how to do this from a CSV file. We can see from an Excel file, and you can also do that from a dictionary. We already saw a dictionary, which is right here, where we have a dictionary. Think of it, you have a bigger dictionary with all the different things, and you can pick data from there. Now if I wanted to pick data from Excel, I would probably say, let me comment this out, the way to pick from a CSV is data frame equal to pd dot read CSV. That's the function that we call, and you give the path of the file where that CSV file is. So I'm going to say CSV, something like this. Next, if you want to do similar with Excel, we'll say read dot Excel, and then here you give your XLS or XLSX file, whatever it is, you give that path here. So these are three different ways you can load data from a CSV file directly, or from an Excel file, and or from a dictionary that is available. We'll look at them in our hands-on, but for now this probably is very helpful, and it's used quite a lot because there are a lot of different websites these days, like Hugging Face, that provides you data sets that are available, and you can use those data sets to get the CSV file and import them inside here directly. Next, we have saving data. Now we can save to CSV and save to Excel. How we loaded the data, there are similar functions. So for example, if I loaded this, I read this files. Now if I want to save it, you will say, let's remove this, since it's a data frame that I'm saving, not a file. So I say df data frame, and then I'll say to underscore CSV. So this is how you can save the file, data or CSV, save the data frame into a CSV file. Similarly, I can just say df dot to underscore Excel to save the data frame into an Excel file that you have, that you can provide. Also, if you don't want the indexing, because it also has index of 0, 1, 2, 3 in the data frame, you can set index equal to false, and it will not add that additional column. If you've seen this column here, 0 and 1, if you don't want that, you just say index equal to false. There you go. This is how you can save it. Now, when you import it or load the data from a particular CSV file, you can load it in a similar way, and it will automatically index it for you. So next, basic data frame operations. Let's look at some of them. We have first viewing data. So if you want to view the data, I am going to go and comment this out. So I am going to say here viewing data. To do that, let's say you have a data frame df, and if you want to see the first 5 rows, you call a function called as df.head. This will, let's say, print df.head. This will print the first 5 rows of a particular data set. If you want to see the last 3 rows or more, you can always say df.tail, which will show you last few rows, but if you specify how many you want, you can see the last 3 rows of a data set. You can also get information summary of a data frame by saying print df dot info. It will give you complete information about the head, the column that uses some statistics that is there. It will give you that. But if you want to get detailed statistics, you can use df dot describe function that will give you statistical summary. This will give you summary of the data frame. This will give you statistical summary of the data frame, and we'll try these out when we work with some hands-on later on today. Next, we have selecting and indexing. Now, if you want to select a particular column, you can directly use print data frame, and then give, for example, we had name as one of the column. It will give you single column, the name column. Similarly, if you want to select multiple columns, you can say df name comma age with double square brackets in here. So this will give you multiple columns, which is name and age in this particular case. We can also look at, so that's for selecting columns. Now, if you want to filter few rows, we can do that by saying print df. Now inside my data frame, I want to filter rows where age is greater than 25. So I can do that by saying df of age is greater than 25. So this will filter rows where age is greater than 25. So you can get a particular data set from a bigger data set. Now, if you want to, next thing that we'll look at is selecting by a particular position. You can get, let's say, for first row by position. If you want to get a data item from the first row, I can just say print df dot ilock of 0. So this will give me the first row by position. If I want to get the first column by position, I say df ilock colon comma 0. This will give me the first column by position. So the first item that is available, first column that is available by position. That's what this does. Next, let's look at selecting by label. So I can do that by, let me just print df dot, instead of I, it's lock. This will give you the first row by index label. And now if you want to get by name column, I can use the same thing as before. You probably guessed it. You just say comma name. So this will give you the name column data item in this particular case. So that kind of summarizes a lot of different basic data frame operations. Now we want to see them in action. So let's go into hands-on exercises. Our first exercise is to load and explore a sample data set. So the objective here is to load a sample data set and explore its structure. So we are going to get a data set from GitHub data structures. We're going to get the iris data set from there, and we are going to use pandas to load that CSV data set and print the first and the last few rows, summary information and statistics. So now to get that particular data set, the URL for that is, let's go here and create a new file. I'm going to call it day 3 exercise 1.py. The URL for that is this one. I am going to open a Chrome, paste it here, and you see this is the data set that we have about iris, which has the about iris flowers, sepal length, petal width, and species of flower that it is, which is setosa or versicolor or virginica. So this is a simple basic data set that is available. So I am going to use that. So as I mentioned, the first step is to import our pandas as PD. So this is the alias that we are giving. Next, I want to load the data set. So for that, I am going to first say load data set. And inside here, I want to say data frame equal to PD dot read underscore CSV. Now this path doesn't have to be local path. I can give this URL that we have right here, and it will read that CSV inside this data frame. Next, I am going to say explore the structure. Now we have defined all these things but never saw any of these in action. So I am going to say print first 5 rows. Do you remember how do we get the first 5 rows? If not, that's df data frame dot head will give you the first 5 rows. So we already saw the data. Let's look at that data again. I am going to say, let's make sure we're in the right folder. Yes, we are. Python day 3 dot underscore ex underscore 1 dot py. It's going to download that data set and it will show me the first 5 0 1 2 3 4 rows from that data set because I called df.head. Next I want to do is last 5 rows. Now if you remember, that is tail. Run that and we have the first 5 rows and the last 5 rows right here. I am going to comment these out because it's going to just keep on growing. Next thing I want to do is I want to get the information about the data set that we have, and we mentioned we can just say df dot info to print it out. Go here, clear it out, run it, and here you go. We have the information about it. It says there are 5 columns: sepal length, sepal width, petal length, petal width, memory usage is this much, and it tells you what are these. There's 150 non-null count items. Data type that it saves is float 62, whereas the last one is an object because it's a text string. So it kind of gives you an explanation about that. Next thing I want to do, describe, which gives me all the statistical information about that data set. So I am going to say run this, and it says count sepal length is 150, which we know all of them are 150. mean for each one of them. What is that? Standard deviation minimum 75% or 25% of data, 50% of the data, 75% of data, max of those. So it gives you all this information from there by just calling the describe function. You don't have to specifically go and find mean, max, standard deviation. It does give you all the information in one single place. Next, let's look at exercise 2. Our exercise 2 is select specific columns and filter rows. So we'll use the same data set that we used, and we'll practice selecting columns and filtering rows based on particular conditions. So we'll select specific columns. In this case, we'll use species and sepal length. We'll filter rows where sepal length is greater than 5.0 and species is setosa. So I am going to just work with the same data set. So I'm not going to create another exercise file. But here I want to select some columns. So I'm going to say selected columns equal to, if you remember, how do you select columns? Double square brackets. And here I am interested in species. If you remember, we have a species, which is the last column here. I think we did here. Species is the last column. That's what I'm going to call. Always copy paste it because it's easier to make sure that you don't do any mistakes. Sepal length is what I'm going to select. These are the columns that I'm interested in. And I am going to print next my selected columns /n, and that is selected columns. Let's see how does it look like. Clear. And here is my species and sepal length data structure, which selected columns have just that, nothing else. So this is my new data frame, which has only the two columns in there, so I can play around with it. Now you can think of it as it can be used for data modeling, where you can take all the lengths, all the different columns except for the ones that you're interested in to predict, and train the model with that. So that's what this can be used for. Next, let's filter the rows. So to filter rows, I am going to create filtered underscore rows, and I'm going to say df. Now in this case, I'll say df of sepal length. Take that, sepal length. If that is greater than 5.0, that's what I was interested in, and I use this rounded bracket because I want to add another condition, which is df of species is of particular type. In this case, I am only interested in, let's take the first one, which is I think setosa. So I'm only interested in setosa. So this will filter only setosas which have sepal length which is greater than 5.0. I can go ahead, I make sure I close everything and print it out. Filtered rows /n, comma, pass the filtered rows to it. I'm gonna comment this out. I don't need that. Clear it out, run it, and there you go. We have 0, 5, 10, 14, 15. These are the ones where sepal length is greater than 5 and the species is setosa. So these are the all the rows that are available with our filtered items that we are interested in. So there you go. This is pretty awesome. I hope you were able to follow along with both the exercises that we've done here. If not, if you had any problems, let me know. You can always look at how this is useful. If you've never worked with data modeling or AI projects before, this is probably new for you, but we'll be using this quite a lot in our later weeks. The additional exercises or additional practice that I have for you is you can load a local Excel file and explore its structure, and then you can create a data frame from a dictionary and add a new calculated column to it. Also try to save filtered data to a new CSV file. Play around with this and let me know if you have any issues or problems, and I'll get back to you. So just to summarize, today we learned the basics of working with pandas, including data structures, loading data sets, and performing essential operations on data frames. These skills are crucial for data manipulation in data science and AI workflows. So I hope you were able to catch up. If not, I would say repeat these functions and learn them again and again. Try with different data sets and make yourself more comfortable with using these functions. If you have any issues or problems or questions, let me know. Day 4, Data Cleaning and Preparation with Pandas. Today we're going to look at how we can make sure that the data that we have is clean and is ready for pandas so we can run different statistic models on them. So first is handling missing values. Sometimes you get the data but there's not all the columns or all the rows have the right amount of data or right data in there or has missing values. So why handle missing values? Missing data can affect analysis and model performance. Pandas provide powerful tools to manage these missing data. So let's see how we can handle these missing data. So there's different methods to handle missing data. First is dropping missing values by drop na function. We also have fill missing values with fill na. Also, we can do linear interpolation where based on the data that we have, we can fill data which is on a similar lines to that particular data set. So that's what interpolation means. Let's look at some examples. I'm going to go ahead and start a Python file, save it in my day 4, call it day 4 underscore samples. And here, let's say we have a data frame df. Now this df, if I want to drop rows with any missing values, I can say df dot drop na. And what this does is drop na, it drops rows with any missing values. So if there is like 100 rows and 10 of them don't have any values in particular rows, it will drop those. Another way is to drop columns with missing values. So we can get rid of some of the columns altogether because that might cause some issues or you don't even need those columns. For example, if you have a data set for property values in California, let's say, and you have some columns over there which talks about weather. Now that doesn't change the value of price because all the houses are in California, and if the weather data is missing, we don't even need that. So we can say drop na, and in this case axis equal to 1. So what this does is this will drop columns with missing values. Next that we spoke about is filling missing values. So if we can't drop some but we need those values, so for example the same data set that I gave example of California houses, now it has salaries of people who are living in, or monthly income is available in that data set, but we have 90% of the data and 10% is missing. So if you want to fill that with, let's say, a zero amount, so you can always say df, for example, whatever the column name is, so let's say in this case is salaries, df, I can say column name, I'm just using generic column name, and I can say fill na of 0. So I can fill a value in there which is 0, which doesn't make sense with salaries, but we'll look at interpolation for that. But you can, if you want to just enter some value and it doesn't matter if it's 0 or some random number, you can save that here. So it replaces not a numbers or anything that is empty with 0. Next is there's two different types of fills, forward fill and backward fills, that you can do by saying df dot fill na and method equal to, if it's forward fill, we take the forward values, you can say ff f fill. Similarly, if you want to use backward fill, you use bfill. So this will enter values based on the data that is available, forward fill or backward fill, which kind of makes more sense, but still in salaries it makes more sense, but still is not the right way to do it. Then we have interpolation. Now you can use interpolation because it kind of uses a linear interpolation here, where you can get the data set, like for example California houses and the salaries, but now you can use linear interpolation to kind of add values that are similar to other houses, just because you want to make sure that there is no empty data set, so no empty columns. You can do that by saying, for example, column name equal to df column name, and then you can just say dot interpolate. That's the function that you call. Where did I miss it? Here, interpolate. So this will add values based on interpolation. So that kind of covers our drop missing values. So there's three different methods, as I mentioned. You drop the missing values if you don't care about it. You fill the missing values if you need the values that are available. For example, sometimes there's data available for 95% and not available for 10%. It might fluctuate your values, but depending on what it is, you want to fill some missing values, you can do that. Or you can interpolate. You add based on the data that is available, interpolate, add interpolation data to the data frame. Next, let's look at data transformation. Now there is three different things that I want to cover here. One is renaming your columns. That sometimes happens where the column is named in a data frame which is not something that you would like or you prefer. So you want to change that. That's renaming columns. You can change the data types. Sometimes you have data sets which are let's say a particular column name. You want to change that from strings to float. You can do that here, or integers to float, or float to integers. You can do that. They change the data types here. You can also add, we also can look at an example of how to convert to date time a particular date that is given in a particular column. And then we have creating or modifying columns. You can modify a particular column. For example, if you have a column with some data, but you want to multiply that with 2, you can do that here. So using data transformation. So I'll give you an example for this. I'll move these down. So let's say you have a data frame, and first you want to rename the columns. So let's say df dot rename, and then inside that you specify the columns that you want to rename. What is its old name? Whatever the old name is, you want to rename that to a new name. You can do that here. So this is how you can rename any of the columns. Next thing that I mentioned about was changing the data types. Now this can be done by saying, let's say if you have a data frame of a particular column name and you want to change the data type from whatever it is, let's say you specify column name and then what type you want. So I want to convert that as type, for example, float. There are sometimes there's data sets that is available in a particular, let's say, integer 64, and you want to convert to integer 32 because PyTorch doesn't work with it, or frameworks that don't work with it. So you can do those transformations using these. You can change the data types like this. df, another one, I'll give you example that I mentioned was converting to date time. So you have data, but that is string, but you want to convert it to date time, and I specify df column name here. So what it does is it takes the existing column and which is string in this case, and will convert to date time for us. Next, I mentioned about creating or modifying columns. So if you want to modify the data in the column, I can say that, okay, the whatever the new column is, or whatever the new column that I want to use the older column, which is, let's say, existing column, and then I want to multiply all those values by 2. Just an example. So create a new column and you modify the value of that column here. So that's is how you can create or modify existing columns. Next, let's look at combining and merging data frames. So sometimes you might get data frames from different places, or it might be, let's say, population data for 1990, 1991, 1992. So you have bunch of different data sets available, but you want to combine them together. You can use the concat method, which will concatenate, which will combine data frames along rows or columns. You can do merging, where you can use the merge function, which merges data frames based on a key or condition. And then we also have joining option using join, which joins the data frames using index alignment. So let's look at examples here, how this works. Delete everything here. So if I want to combine two different data frames along rows or columns, I can say let's see for rows first. Let's say combined data set. You can say PD dot concat, that is the function. I'll say I want to use data frame 1 and data frame 2. I want to combine these data from axis of 0 for rows. Similarly, if you want to do it for columns, all you change is axis equal to 1. So first one will combine the two data frames along rows. The second one will combine the data frames along columns. So depending on how you want to use it, you can use these options. Next is about merging, as I mentioned, which merge data frames based on a key or condition. So I can have a merged data set from PD dot, as I said, the function is merge, where you create the first data set, give the first data set, give the second data set, and then on which column, which common column do you want to merge them on? Common column. So let's say you have data about houses and you have data about the people, and then you want to merge both those data sets based on the salaries of or income of that particular look of house. So you can do that using this. Next, if I want to do more on the, now if you're familiar with data sets, this is the first one was merging on a common column. But what if you want to do left join or inner join? So let's look at how would we do a left join. So I can say pd dot merge df1 data frame 2, and then you can say how equal to left and on which column, what is the column that you have, common column in both the data frames, you can specify that. So this will do a left join. If you want to do inner join, you can just say inner here and specify the common column, give both the data sets. So this is almost same as this function, just that how parameter changes. Next, about joining. Now, joining data frames using index alignment, you can do that similar to above. I can say joined equal to df1 dot join, and you pass the df2 here, and you can say how equal to inner, or you can say left, just like before. But this is how you can join data frames using index alignment without the column, just the index alignment. This is what it does. Now that we learned some of these different combinations and how to play with data frames, let's go ahead and work on a hands-on exercise. Our exercise 1 is to clean a data set by handling missing values and renaming columns. The objective here is to practice handling missing data and renaming columns. What we're going to do here is we'll load a data set with missing values, then fill the missing values in numeric column with the mean, and then rename the columns to follow consistent naming convention. So let's go ahead and create day 4 underscore exercise 1.py. Now here first I am going to import my libraries, which is pandas as pd. I'll also import numpy as np. So I'm going to use everything that I've learned in the previous days. Then let's create a data set, a sample data set. Since we don't want to use anything that is available, I'm going to create one here, a simple easy one, where I have names. Names I can enter as a list of, let's say, Alice. We have Bob, and then we have np dot not a number, it's a missing value, and then I have David here. So these are my names. Then I have age column, and this has different values. 25, Alice is 25 years old. I don't know the age of Bob, so I'm going to say np.nan. The third person, I know their age is 30, but I don't know their name, and 35 for David. Now for their scores, let's use, instead of grade, we can use score. This code 85, 90. I don't know how much this person scored. There's no data available, and 88 for the last person. Okay, so I have my data set available. Now I'm going to say df dot pd. So this dictionary that I have, I'm going to convert that into a data frame, which we saw how to do it. We just call the data frame function and pass the data to it. So we converted the dictionary into a data frame. Now that I have it, let's print our original data set of how it looks like slash n comma it's df is what we're going to print out the entire thing, because we don't have much data, only three columns and 4 rows. Now next I'm going to fill in the missing values. Let's run it just to check it out. So I'm going to say python day 4 underscore exercise 1. So here, there you go, 0 1 2 3 4. It indexed them, not a number, not a number, some missing values here and there. So now let's fill the missing values. I'm going to say df age. For age I can just say df wherever there is an age which is missing values, fill not availables with df age dot mean of all the different columns. So based on the mean, just fill this. So it will probably be, I would say, around 30ish. So let's see what it does. So that's the first part. I'm going to say for score, I'm going to say df score. I will interpolate in this case. It's called the interpolate function. So based on the straight line, it will add some values based on the values that we have here. Now, if I want to print this thing, I can check it out. Let's go here, clear it out, run it, and this is the original data set. Now if you look at the age, if you see Alice age, Bob's age is 30, which I mentioned, as it will be 30ish something. Score, if you see, it's 89. It's interpolated based on the values that we have here. So even if this person never gave the score, he's the not a person, no name, or scored more than Alice and David. 89. Pretty good based on interpolation. Next, let's rename some columns. Let's see how we can rename columns. So I am going to say df equal to df dot rename. Now in this case, I want to rename, let's say columns equal to, I will say name. I want to change that to, student underscore name. And then I want to change score to exam score. That's what I'll specify. And then let's print this entire thing. If you saw earlier, it still kept the same names. Now when I do this, clear it out, run it, we have the new student name, exam score is available. Now I can drop this one which has doesn't have a name, but I don't want to right now. I'll keep the way it is, and this is our data set that is available. So this is what I want you to do. If you were able to follow along, good. If not, do so and let me know if you have any problems. Our second exercise is to merge two data sets and perform data transformation. The objective here is to combine the data sets and apply some transformation. What we will be doing is we'll create two data frames with a common column and perform an inner merge based on the common column, and then finally add a calculated column to the merged data set. So let's go ahead and do that. So I am going to create a new file, day4 underscore ex2.py. Okay, let's copy these are always required most of the times, and I am going to create my first data set. I will call data frame 1 equal to pd dot data frame. I'm just directly gonna call this instead of creating a dictionary, and pass it a dictionary inside it, where I'll say id is a list of 1 2 and 3. Next I'll say name is Alice, Bob, and Charlie. Okay, next one uh, is, let's use age again, and this time I'll say 25, 30, and 35. So I have my first data frame. Now the second one I'll create with the same IDs. So I'm going to say df2 equal to pd dot data frame, and this frame I will give IDs are same, so I'm just going to copy this and paste it here, and then I'll say scores that these students have scored are 85, 90, and 88. So I have these scores available. Next, let's print them and check this out. So I have my first data set slash n comma df1, right? And I have my second data set, I'll call it data set 1 and data set 2, df1 and df2. So I have my two data sets. Next, I want to merge the data sets. So to merge, I'm going to say merge data set equal to pd dot merge, that's the function that I'll call, pass the first data set, pass the second data set, and then how do I join it? I said I want to use inner join. And what is the column that I want to join it on? On ID. So I will say ID. Perfect. Next, let's print and see how does it look like. Merge data set slash n comma merged. So that will give me my merge data set. Now let's add a calculated column to it. So we'll create another column and add to it based on the data that we have. I'm going to say merged. Let's create score percentage. And this percentage will be merged data set wherever the score is, whatever the score is. Okay, I think I have to use this bracket here. Divide by 100 times 100. So this is the percentage. And this I'll say print, and I'll say transformed data set slash n comma merged. I kept the name same, so that should not cause a problem. So let's go ahead and run this. I hope you were able to follow along. If not, pause the video, just make sure that you are at this point, and then run python day 4 ex2 actually. So I'm going to go ahead and say ex2, and there you go. Our data set initially 1 to 3, first data set, Alice, Bob, Charlie, their ages. We have their scores here. Now it's a merged data set 1 to 3, Alice, Bob, Charlie, 25, 30, 35, and their scores here. Transform data set, I got the percentage. Now this is out of 100, so of course the values will be almost same unless I change this being out of 200, then it will be 200, and will be half of it, most probably 42, 45, and 44. So that's how this works, and I've created it. So this can be helpful even in like this data set where you have a data set with all the students and you have their scores in a different data set, and then you want to also calculate the percentage, so you can use this entire data set to get what is the overall percentage of students that you have, or how many of them passed, or what is the grade level in there. So you can use this data set for additional calculations. Now, now that you've completed this, for additional practice, you can drop columns with more than 50% missing values. You can merge three data sets and analyze relationship between them. You can also do convert categorical data to numerical using one hot encoding. If you don't know what that is, look it up, but we'll be covering that in the future. So just to summarize, today we learned how to clean and prepare datasets using pandas, focusing on handling missing values, renaming columns, and combining data frames. These skills are essential for pre-processing data in data science and AI workflows, and we'll be using this quite a lot in every single project. So if you had any issues or problems, let me know so we can catch them early, and then you can move on to the next days. Welcome back to day 5. Today we are going to cover data aggregation and grouping in pandas. Let's start with grouping data by categories. So now why group data? Grouping data allows you to perform operation on subsets of data based on shared categories. We can do group by using group by in pandas. The syntax for this is something like, let's create a new file first, Python, save it inside day 5. I'm going to call it day 5 underscore samples. And here, let's look at the syntax. So grouped equal to data frame dot group by, and then you select the column name here. So that's how you use, that's the syntax for group by. So now let's go ahead and look at what are the different operations that are available. Now first you can go over, iterate over groups. So you have a bunch of groups, and you can iterate over this by name and group. You can do that by saying, let's go ahead and say, for name comma group in grouped above. So this group that we have, I can print name, I can print group. So based on that, it will iterate over the groups, and you can display the name and the group out here. Another operation is to apply aggregation. This can be done using, you can say, grouped dot mean. This is a function that you can use, and you can also say grouped dot sum. So you can apply these aggregation functions to a grouped category. Next, let's look at aggregation functions. So first is using group by. We can combine grouping with aggregation methods. We can do that by saying something like this. I can take a data frame, and say group by, and to that I can specify a category column, let's say, and then I can say numeric column, numeric underscore column, and then directly give mean to it. So this will give me the mean of that particular columns grouped together. Next is, I can say group by category underscore column dot agg. Now this is the aggregation function where you can specify the numeric underscore column, and of that column you can specify in a list format of what all you're looking for. For example, I can say I'm looking for mean, max, and looking for min. It will do that all together. This is the power of group by, where you can combine grouping with aggregation methods. Next, we have using the pivot table. Now you can reshape the data with aggregation if you use pivot table function. So that can be done using, let's say I say pivot equal to data frame dot pivot underscore table, and to that I can say values equal to numeric underscore column. I can say the index that I want to use is category column, and the aggregate function that I want to use is mean. So this is another way using pivot table you can do this. Another aggregate function that we can do is custom aggregation. Now this you can apply custom function using agg function. So that can be done using, I can say, let's say I create a function called as range underscore function. This is my range function which takes an input of, let's say, x, and then I can say return x dot max minus x dot min. Now if I want to use this range function, this is my custom aggregate function, I can say df dot group by category column numeric this numeric column dot right here dot agg. Actually, this doesn't need like group by category column of let's close this of numeric column dot agg range, the function that we have created, range function, and it will pass those values and it will group by based on this custom function. And we'll be doing a lot of these in our hands-on, so if you don't understand exactly how it will work, I'm going to show you some samples in the in the hands-on. So that's what we just saw. We saw the app, how to apply custom functions using AGG here. We used this range function. We created a custom function and we applied to that, which is x max minus x min, which will kind of give you the difference between the maximum and minimum. Next thing that I want to look at is calculating summary statistics for group data. So if you have group data, how do you get the statistics for it? So some of the common statistics that you can get are mean, max, and min. So I'm going to go here. I have my category column. Now to get the mean, I can just say mean something like this. Let me just make sure that I keep the previous one. Move it up. So a category column, and then here I can directly use the mean function and get mean from it. Similarly for max, all you do is change this to max. And now I know how I know you know how to do min is this way. So these are the three functions that are common statistics that are available for us. Now if you want to do multi aggregation, that's our next topic of how to do multi aggregation. That you can do in a similar format which we saw a little bit earlier, group by, and here I can just say dot aggregate, which applies to numeric column. Close this, and of this I am looking for, what am I looking for? Let's make sure everything is closed. I'm looking for mean comma max, max comma min. That's what I'm looking for, and this aggregation function ends at the end here, something like this. And if you want to format it nicely, you can always have it this way. So now I'm grouping by multi-aggregation, where I'm saying I have to group by based on mean, max, and min. That's it. So these are different things that I wanted to cover inside inside data aggregation and grouping in pandas. Now let's go ahead, and to understand it better, let's jump into hands-on exercises. The first exercise that we are going to do is we are going to group data by a categorical column. So we'll load a data set and group the data by categorical column. First, we'll load a sample data set with a categorical column inside it, and group the data by categorical column and calculate the mean for each group. Those are the steps that we'll follow. Pretty much 2 steps that we'll do to see how all this works comes together. Save this. I'm going to create a new file. I'm going to call it day5 underscore exercise1 .py. Inside this, first let's import pandas because we are using the pandas functions. The sample dataset, let me create a dataset here where I have class which is A, B, someone else got A, then someone got B, someone got C, and then I'll use one more C here. So these are different classes that are available. Next, I'm going to say the score for each one of these is, let's give some numbers, 85, 90, 88, 72, 95, and 80. So I have my numbers. Next, I am going to create a one for age where it will show the ages. I'll say 15, 16, 15, 17, 16, and 15. So I have that. I have 3 columns here: class, score, and age. Now let's create a data frame out of it. It's very easy, as you've done it already so many times, data frame, and pass it this data. So I'm creating a data frame from a key value dictionary. Once I have that, let's print out the original data set slash n, and to this I'll pass df. So I have my data set. Now let's, as I mentioned, group by class and calculate the mean. So the categorical the categorical column that we're going to select here is class, and we'll calculate the mean. So to do that, I'm going to say grouped equal to, I'll take the data frame and I'll say group by, and I'll select the categorical column class, and I'll look for mean. Now let's go ahead and print this out grouped. Let's see how does it group back. I'm going to go back here, ls, and I'll say python day 5 underscore ex1. Run it. This is my original, as you know, abc abcc, and these are the score, and this is the age. Now here it's grouped based on this categorical class a, b, and c. They're grouped together based on class. That's what we mentioned, and it got a score. So if you got the mean score for a, which is 86 based on this and this, b, it got based on this and this, 81, and c. So it grouped them properly and gave me the statistics of mean for this particular project. Next, I'm going to do exercise 2, where we will calculate the summary statistics for group data. So the objective here is to use grouping and aggregation function to calculate summary statistics. Uh, First, what we'll do is we'll group data by a categorical column class that we've used before, and then calculate the statistics like mean, max, and min for numeric columns. So we already have created this project, so we can just work off this. I am going to comment this out. I have my original data set. Now if I want to get the stats, I'll say stats equal to df dot group by. I want to group them by class, and since I want all the different aggregates, and I want it for, let's say I want it for score this time, same as before. And here, what are the different things I want? I want mean, max, and I want min. Now, if you want to add also age, because we did that before, you can also use age, and inside this I can copy and paste the same stuff. Now let's print this out and see how does it look like. Go back here, clear, and there you go. So we have the class ABC, and mean, max, and min are calculated and given to you in a nicer data set for both score and age in two different columns, and they have sub columns for mean, max, and minimum. So there you go. This looks like what we wanted. We grouped the data based on the class, and we got all the summary statistics for this grouped data. I hope you were able to follow along and understand. If you have any questions on this, let me know. It just helps you group different types of data types together and then get mean, max, and min, or different statistics information based on what you're doing. Another option is, if you want to do some more additional work, you can practice with creating a data set of sales data and group it by region or product category. You can find these data online, so you can pick that. You can use the pivot table to calculate total sales per region and per year. Also, you can create a custom aggregation function to calculate the variance for each group. And again, while working on these, if you have any problems or questions, let me know and I can help you out. So to summarize, today we learned how to group data and calculate summary statistics using pandas. These techniques are fundamental for aggregating and summarizing data in preparation for analysis or visualization of the data when we are doing some AI projects in the future. Day 6, Data Visualization with Matplotlib and seaborne. Now, what's the fun in working with all the data if you can't plot your data? So this day is dedicated to that. Let's start with introduction to matplotlib for plotting data. Now, what is matplotlib? It's a foundational Python library for creating static, interactive, and animated plots. It allows for detailed customization of plots. Let's look at the basic syntax for using matplotlib. So I'm going to go ahead and create a new file, Python, save it in my day 6. I'm going to call it day 6 underscore samples. And here I am going to first import matplotlib dot pyplot as plt. I'm going to use that alias. Now let's do a basic plot. So I'm going to call it basic plot. To do that, let's say if I have a list of items x equal to 1 comma 2 comma 3 and 4, and then I have y which is say 10 comma 20 comma 25 comma 30. So these are my basic x and y. And if I want to plot this, I can just say plt dot plot, and x and y is what I want to plot, and if I want to see it, plot dot show. As simple as that. Let's go to our terminal, clear it out, and I can say Python day 6 underscore samples, and there you go. We see our plot here, x-axis and y-axis, and based on the coordinates that I've given, it has plotted that plot here using matplotlib. Next, let's look at some basic plots. We have the line plot used to visualize trends over time or sequences. We just saw one which is similar to that, but we can create another one. What I can do here is I can say plt. I can keep this actually just for future. So for line plot, let's say line plot plt dot plot. I can directly use that, and instead of creating variables, I can say 1 2 and 3 here, give the first list. I want to give the second list, which is 10 20 and let's say 30, and I am going to give label equal to trend plt dot title. I'll give it a title. In the previous one we didn't give title, so this will give you an idea of where the title shows up. I'm going to call it line plot. I can give other attributes like x label, which will give a label to the x-axis. I'm going to just call it x-axis, and next I'll say plot dot y label. Again, as you probably guessed it, we'll call it y-axis, and then next I am going to say plot dot legend, create a legend for this, and plt dot show. So now if I run this, I have a straight line because 1 2 3 10 20 30 will be a straight line. You see x-axis, you see the line plot, y-axis, all those labels are displayed. So this is a simple line plot. Next, let's look at bar chart. Now bar chart, as you probably have seen, is a bar of bars displayed. So for that, comment this out, go up here, go up here and say bar chart. And this, what it does is used for categorical data comparison. That's what bar charts are usually used for, whereas line plots were used to visualize trends over time or sequences. So I am going to say categories equal to, I'm going to create a list of categories, and just to make it simple, I'll call it A, B, and C category. Next, I will create a values list which will have, let's call it 10, 15, and 7. You can probably already draw the bar chart in your head. So I can say plt.bar, and here I'm going to say categories. I'll pass categories. I'll pass the values, and I can also pass color in this case I am going to use, let's use blue color. Plt dot title. For title I will give bar chart, how original, and then say plot dot show. Run this. Oh, okay, this is still running, I guess. Run this again, and there's my bar chart with my values, which are A, B, and C categories, and I have 10, 15, and 7 displayed right here, and the color is blue. You can change that to whatever you want, customize it to however you want. Next one that we're going to look at is histogram. Now, histogram shows the distribution of a data set. So for that, comment this out first. And the thing that we want here is histogram. For histogram, I'll give a data set. I'll use 1, 2, 2, 3, 3, 3, 4, 4, 4, and 4. Bunch of data set points here. For plotting histogram, you say plot.hist, and inside here I have to give the data. Next, I need to get how many bins I need to create for this histogram. I'm going to say I'll create 4 bins. Color that I want to use equal to green, since we used blue last time. And there's also something called as edge color. I use black for that. So that's how you create it. Now I can give the same all parameters. I'll just give title for this again, histogram, and then I'll say plot dot show. Save it, run it here, and I have my histogram with all those 1s, 2s, 3s, and 4s displayed right here in a histogram format. And we have 4 bins, and it has color green, and the edge color, which is black, is displayed there. So that's it. I'm going to close this up. Make sure this is closed, clear. Next thing that I want to talk about is scatter plot. Now, scatter plot visualizes the relationship between two continuous variables and used quite a lot in AI projects. So I am going to go back here, comment this out, x, or just say this is scatter plot x equal to, let's give it some numbers, 1, 2, 3, 4, and 5. I want to give some numbers to y, probably 10, 12, 25, 30, and 45, some random numbers. Now to create the scatter plot, I call plt.scatter or plot.scatter, give x and y, and the color for the scatters I'll give red. Plot.title, I'll call it scatter plot. Next, finally, just say plot.show. Let's look at how the scatter plot look like. Run this project, and there you go, a scatter plot. So think of it, if you have like a big data set, how it will look. And that's what you see quite a lot these days when data scientists talk about their scatter plots or data items, or how it's scattered and how they are classified into different places. And so this is very useful for building things in future. So I'll go ahead, clear this out. So that's all that I have here. Next, let's talk about customizing plots. Now we saw that we can add title, X label, Y label, legends, all those things. What are the different things we can do in here? So we can add, as I mentioned, titles, access labels, we can give legends, we can adjust the colors and styles. So let's look at some of those things that we can do. I'm going to use this exact same thing here that we have here. We already gave a title. We can give X label as X axis label. I can do the same thing for Y label, Y axis label, and I can also give a legend. For now I don't have any legend, so I'm just going to create an empty list and call it dataset1, something like this. Go back, run it, And we have this here. You see the legend on the top. I can give multiple legends in the list, and you see the entire x-axis and y-axis. Title is already given, scatter plot. I can also change the colors. So when I plot a particular thing, for example, if I want to uh, plot, let's use one that we plotted earlier. So I'm going to comment this out, go here, and when I plotted here x and y, we gave the label as trend, and then we can also give color as, let's say, orange. I can give what else can I give? I can give line style, because this is a line graph, equal to, if I want to give dotted, I can just say dash and dash, and I can give marker equal to small o, something like this. If I run this now, let's make sure that our plot is closed, clear. Run it again, and there you go. Our dotted lines are orange. We have color orange, line style dashed because of this, and marker is 0. That's what I've given here. You can also use x for this, and there you go. Now we have x points over there. That's how it looks like. So these are different customizations that you can do to plots. Clear this out. Next, let's get introduction to Seaborn for advanced visualization. Now, what is Seaborn? Built on top of Matplotlib for easier and more visually appealing plots, Seaborn was born to bring some more customizations to Matplotlib. It provides a high-level interfaces for statistical graphics. Some of the common Seaborn plots include, we have the heat map, which visualizes a matrix of data. We have pair plot, which shows pairwise relationship in a data set. We can kind of test these out. What I'm going to do is I am going to take this same project, import Seaborn as SNS. Next, I am going to import NumPy as NP. So now let's get some data. Data equal to np dot. I'm going to just create some random integers here, random numbers of 5 by 5, and then I'll say SNS dot heat map. This is for the heat map that visualizes a matrix of data. So you can give the data to that, since we created that matrix data above. I'll say annotations equal to true, and then cmap equal to, it has bunch of different uh, things that you can use for colors, and for that I'm using cmap, which has bunch of different options. I'm going to use cool warm. Next, I'm going to say plot dot title is heat map, and as usual plot dot show. Save this and I'll run it here, and there you go, our heat map. Pretty cool, right? So based on the matrix that it created of 5 by 5 matrix, it has this 1 2 3 4 5 1 2 3 4 5 items here, and it shows the heat based on where the numbers have been randomly created. Of course, every time you run this, it will look different because I've not given a seed. So if I run it again, it will look a little different from the previous one, because it randomly generates these numbers and then makes this heat map out here. Next, for pair plot, which shows pairwise relationship in a data set, you'll have to say, instead of saying this, we comment this out, you say SNS dot pair plot, and then to that you'll give a df, which is the data frame, which I don't have it right now, but we'll see in one of our hands-on example. And then you say plot dot show. That will give you or show the pairwise relationship in this particular data set, and we'll look at those in our hands-on. But that's those are the two different heat maps and pair plots that you can do using. So these are the common seaborn plots that you can build. Next, let's run to our hands-on exercise. So based on whatever we have learned, first exercise, we're going to create basic plots with Matplotlib. The objective here is to plot a line graph, a bar chart, and a scatter plot. So what we're going to do is we're going to create data for trends, categorical comparisons, and relationships. And then we're going to customize plots with titles, labels, and legends. So let's get started with exercise 1. I'm going to close this and create a new file. Save it as day 6 underscore exercise 1 dot py, and make sure my other projects are closed. I'm going to close this, go back to here, clear this out. Now, to start with, first we need matplotlib. Import matplotlib dot py plot as plt. So first step is to create a line plot, but for that we need some data. So I'll create an object variable called as years, and inside this I'll say 2010, 2011, 2012, 2013. I will say sales number for these years include 100, 120, 140, and 160. Good sales numbers increasing, of course. plt dot plot, I'll pass the years as x and sales as y, and then I'll say label equal to sales trend. I will give a color of blue, even though it's very bright. I'll use the marker of O, and then I'll say give a plot dot title of sales over years. Next, I'll say plot dot x label. I'll give x label as is our years, so I'm going to say years. plt dot y label is our sales, so I'm going to say sales. And then let's display the legend and display the plot. Do this, go back here. It's already cleared. I'm going to say Python day 6 underscore ex1, run it, and we have our line plot here based on the years and the sales. So that's pretty cool. We have the legend over displayed. Perfect. Next thing that I want to do is a bar chart. So I can say bar chart. I'll create different categories. For this, let's use electronics. Another category is clothing, and another one is groceries. You can pick whatever you want. I'm just using randomly. Revenue for these is, let's say, 250 for electronics, 400 for clothing, and 150 for groceries. Now I'm going to say plot dot bar because I want to display a bar chart. I'll pass it categories and revenue and give a color of green. Then I can say, oops, plot dot title. I'll give it a title. I'll say revenue by category and show this plot. Now if I run this, I have my line plot. Close this. I have my bar chart. I should have commented that, but if you close that, the next one will run and show you your categories. You'll show your revenue here, and we have three different numbers: 250, 400, and 150, depending on what it is, and that's why it is up and down. It's a bar chart. So there you go. We have our bar chart. Next thing that I want to do is the scatter plot. So for this scatter plot, what you need to do is first use let's say hours studied, of how many hours I studied. If I study 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours, what's the difference? Exam scores based on how much I've studied. So if I study 1 hour, I get 50, 55, 65, 70, 85. Just from the graph you can say, depending on how much you studied, better you scored in your exams. Next, I'm going to say plot dot scatter. I'll pass this hours studied, pass this exam scores, and I want to display red as color for these plot these scatters. Plot dot title, study hours versus exam scores. I'll say plot dot x label is hours studied. I want to use a y label too. I'll call it exam scores, and then finally I'll say show me this plot. Run this, and I have my exam plots based on how much more I've studied, more I score. So these are the three charts that we created. We created a line graph showing sales trend. We did a bar chart showing revenue comparisons, and then we did a scatter plot showing the relationship between study hours and exam scores. So I hope you were able to follow along. If not, let me know and I can help you out. But let's move on to exercise 2, where we will be creating a heat map with Seaborn. So the objective here is we'll use Seaborn to create a heat map from a correlation matrix. Instructions that I can follow here is first I'll load a data set and calculate the correlation matrix. Then I'm going to visualize the correlation matrix using a heat map. In this particular case, I will be loading up that same iris database that we loaded earlier in one of the days this week. So I am going to go here and create one for day 6 underscore exercise 2.py, and this is the URL that we're going to get the data from. So first let's get pandas as PD. Next we need Seaborn as SNS. Next I want to use the matplotlib.py plot as PLT. So I have these three. Next, let's load the data set that we have. So I'm going to say pound, let's copy this from here, load data set, and I'm going to say df equal to pd dot read CSV, and this CSV is coming from this URL. So I have my data set. Now, next, let's calculate correlation matrix. To do that, I'm going to say correlation. This is just a variable, so it doesn't matter if there's a typo. Say df dot corr. That's the function that will give us the correlation matrix for the data that we have, which is the types of petals, the petals we have. Next, I am going to say plot the heat map. Now to plot it, I'm going to say SNS dot heat map. I'll pass the correlation. Where is it? Correlation matrix. Next, I will. Should have some equal to. Next, I want to give annotation equal to true annotated, and CMap. If you like the previous school worm, I'm going to use the same heat map. Plot dot title equal to correlation heat map. Next, I'm going to say plot dot show. So this should show me a heat map with annotation showing correlations between numerical columns in the data set, which is our, if you remember this, I can open this up again in Chrome. And there you go, sepal length, sepal width, petal width, and species. So I will run this up in my, okay, I think we have a graph running. Close this, clear Python day 6 underscore ex2.py. Run this, pull the data, could not convert string to float for Setosa. The last column that we have over there is is not numbers, is not numerical, so it will cause problem for that. So what I'm going to do is I'm going to drop that column from my data frame. So to do that, I can just say del df, and that column was called, let's open that data set again. It was called species. Go back and I'll say drop that. Let's go back, clear it out, run it, and now we have it based on the other items that we have: petal width, petal length, petal sepal width, petal length, and petal width. It has the heat map depending on how the correlation matrix shows up. So if I hope you were able to follow along with this. If you have any questions or had any other issues, not something that I'm facing, let me know. For now, for additional practice, you can look at how to create a histogram with multiple data sets overlaid. That's one thing that you can try. Next, you can try is use Seaborn to create a violin plot or box plot for visualizing distributions. Next, try to combine multiple plots in a single figure using matplotlib's subplot. So try this out and let me know if you have any issues or problems. So today we learned how to visualize data using Matplotlib and Seaborn, focusing on basic plots, customization, and advanced statistical visualizations. Now these skills are crucial for presenting data and uncovering insights in data science and AI projects that we'll be working on in the future weeks. So let me know if you were able to follow along. If you had any questions or problems, let me know and we can move to the next day. See you tomorrow. Day 7, Exploratory Data Analysis, or something called as EDA project. So here on day 7, we are going to create an exploratory data analysis project. To do that, let's look at all the different steps that we need to follow. First, applying data manipulation and visualization for EDA. So what is EDA? Exploratory data analysis involves summarizing data sets to uncover patterns, relationships, and insights. Now, the steps in EDA include first data cleaning, handle missing values, remove duplicates, and fix inconsistencies. We have seen that before earlier this week. Data transformation, changing data types, normalize data, and create new feature if needed. And that's also something that we saw this week earlier. Aggregation and filtering, summarizing data and applying filters to focus on specific aspects. Again, something that we've already covered this week. So we are going to put all these steps together, and that's what is called EDA, or exploratory data analysis. Next, let's look at identifying patterns, trends, and correlations. Some of the visual tools that we use for these insights include line plots for trending data over time. We do bar charts for categorized comparisons. We use scatter plots to find relationships, and we use heat maps for correlation analysis. And we already learned how to build all these line plots, bar charts, scatter plots, heat map. Using Matplotlib and Seaborn, we can build any of these. Next, the key patterns that we are looking for is relationship between variables, which is correlations. We're looking for distribution of variables, how to build histograms, box plots, and we'll find the outliers or anomalies. These are the patterns that we're looking for. Let's talk about the summary statistics, visual insights, and hypothesis generation. Our first thing, summary statistics, we have already seen how to get these. You can create a data frame and call the describe function, which will get you the mean, the standard deviation, the min values, the max values, and much more. So that's already taken care by the data frame's describe function. We have df.correlation, which provides your correlation matrix, which we looked at when we created a Seaborn matrix earlier this week, where we took the iris data about all the petals of flowers and we created a correlation matrix over there. Next, about hypothesis generation. Now formulate hypothesis based on observations. For example, we're going to take Titanic data set in this particular today in our project in a hands-on, and one of the examples over there is passengers in higher Titanic classes have higher survival rates. Is that true? Is that the hypothesis that is true? Now you can use EDA to validate or refute these hypotheses, and that's what we will be doing. So we take the Titanic data set, and our hypothesis is passenger in higher Titanic classes have higher survival rates. Now, based on common sense, or if you even watched the movie, you probably have seen higher Titanic classes customers over there were allowed on the deck and they could get out of it there easily. Whereas passengers in the lower classes were locked downstairs. So there's much less survival rates for them. But at the end of the day, you know what happened. But we are going to use the data set now to kind of validate or refute these hypotheses using EDA. That's what we will be doing. So let's jump directly into our hands-on EDA on a sample data set, which in our case will be picking up Titanic data set. The link I'll provide you in a second, but our first task in this particular project will be to perform data cleaning, aggregation, and filtering. The data will be available using this URL, which is something similar to Irish dataset. It's a CSV file here, Titanic CSV, which is available in GitHub usercontent.com slash data science dojo slash datasets master titanic.csv. It has passenger ID, if it survived or not is 0 and 1, PC class, what class they belong to, third class, first class, name of that person, sex, age, SIB SP, barge, tickets, fare, cabin, and embarked. So it has all this information that we can use, and it has a bunch of data available for us. So using these data set, so we have from passenger ID 1 all the way, okay, let's close this, all the way to passenger ID 891. We have these many records. Now, again, this data set might not be clean, so we will be performing data cleaning, as I mentioned, aggregation and filtering to this particular data set. So first step that we'll be following here is load the data set and inspect its structure. Then we will handle the missing values, duplicates, and inconsistencies in here. Then we're going to apply filters or aggregation to summarize specific groups. So let's go ahead and create a project. I'm going to start a new project, Python file, save it as day7 underscore ex. And here I am going to first import pandas as PD. I need to load the Titanic data set, so I'm going to copy this URL. You can take this URL from here, load Titanic data set. Let's get the URL equal to, again, it's https raw github usercontent.com data science dojo datasets master titanic.csv. And then I'm going to create a data frame out of that, pd.read underscore csv, and pass the URL to this. So I have loaded my Titanic dataset. Next, let's inspect the data. So for that, I am going to say print df.info, get some basic information. I'll also get some stats of it. So I can say df.describe. And so let's run this just based on what we have right now. I'm in the right file. I am going to say Python day7 ex.py, and here is our first few rows, the first info about this particular uh, right here. The information is available here, passenger ID survived, all these different columns that are there, not null, non-null count. If you look at it, some of them don't have age information. The cabin information is not available for all the data sets. There is 889, 891. So there are some things missing in here, as what we can say. And this is the basic describe, which gave us some stats on count, mean, standard deviation, minimum 25%, 50%, 71%, and max of the values that are in the data set. So that's pretty good. I'm going to take that data, and first what I'm going to do is I am going to handle the missing values. What do you recommend we do here? So as I mentioned, there is probably age which is not, which is missing over here. I am going to give a median of based on the other ages that are there. So df age dot fill na wherever is not available. I will fill df age dot median. That's what I'm going to fill here, which makes sense because ships back then were taken based on a particular age criteria, and whatever is missing we can just fill that by that. We'll also take the embarked data, which is I think there. Let's see, embarked, which is 889 non-null. I'm going to take that, and over there I'll fill the mode for it. df oops embarked. For this I am going to say if not available, I will use df embarked dot mode of 0. So that's what I'll fill this with. So that will kind of takes care of our handling the missing values. Next, let's remove some duplicates. Let's see if there's any duplicates and remove duplicates here. Even if it doesn't have duplicates, it's a good idea to run this df dot drop underscore duplicates. Just running this function will drop duplicates. You don't have to do anything special for this. So why not just use it anyways? Because having duplicates will kind of cause problems in your data set. Say filter data, next one, passengers in first class. So let's do that. I'll say first underscore class is a variable that I'm creating, and here I am going to say df, and for that I think we use p class as you've seen equal to 1. So this will give me all the first class passengers, all data for that, and I can say print first class passengers slash n comma first class dot head. Just let's look at the top 5 of them. I'm going to save this, go back here, clear it out, run that project, and we have the data here. So we are displaying the information again. We're displaying the description with all the different count, mean, median, everything here. And then for passengers with first class, I'm displaying their information or just the top 5 of them. So that's our task 1. Our task 2 now is to generate visualizations to illustrate key insights. So we're going to create visualizations for trends, comparisons, and distributions in this particular case. So what I'm going to do is I'm going to go back here, and for visualizations we need matplotlib dot pyplot as plot. Next I'll say import seaborn as SNS. That's what I need. Now to build, now I'll go all the way to the bottom. Now first I want to display a bar chart. This will display survival rate by class. Now to do that, I'll create a variable survival by class equal to df dot, I'll use that group by that we have learned earlier. Group by, pass the p class as the class that I want to display, and then I'll get survived out of that. So group them together and get the mean out of it. So that will give me survival by class. Next, I'm going to use the survival by class and plot kind equal to bar and Color, let's use sky blue this time. Make it a little bit lighter. Sky blue. Next, I'm going to say plot dot title. I want to use the title as survival rate by class. I'll use plot dot y label. I'll not create x label. Survival rate, since it's a bar chart, and then plot dot show will show me that bar chart. So let's run this and see how does it look like. And there you go. We have our bar chart in sky blue, which looks much nicer than others. Now, depending on class, what is the survival rate? So from the data itself, we can say that more people survived in first class, then second class, and then finally third class. Next step, let's first close this. I'm going to clear this out and then go back here. And next, we're going to create a histogram of age distribution. So I'm going to say histogram age distribution. So I'm going to use Seaborn for this. So I'll probably say SNS dot hist plot, and I'll use df of age, comma. Next thing is my KDE equal to true. Next, I want to give how many bins I want for this histogram, which is I'll select 20, and color equal to, I'll use purple this time. Next, I'm going to say plot dot title. I'll say age distribution. Next, I'm going to say plot dot x label is age. Plot dot y label is frequency, and I'll say plot dot show. I am going to comment this out so that doesn't draw on top of this. So we have our histogram. So let's go ahead and run this. And we have our histogram displayed depending on the age distribution. So depending on what your age is, that's how many passengers that were there in Titanic. So see, most of them are focused towards from 25 to 30 around, I would say. So that's the data that we have. Now close this, clear this out, go back here, comment this out. The next thing that we want to do is a scatter plot of age versus fair. So I'm going to say scatter plot, and this is age versus fair. So for that, I'm going to say plot dot scatter. I'm going to use age for it, age. I'm going to say df y-axis is another thing that I'll use is fair. Then I'll say alpha is how much transparent I wanted, 0.5. Next is color equal to green. I'll use that. I'll give a title this time as age versus fair. I'll give the X label as age. I'll give Y label as fair, and I'll say plot dot show. So let's try this out. And there you go, a scatter plot, age versus fair. So depending on how much more older you are, more you're paid. Nope, it's actually, this is where most of the scatter is, which is that the fare that you paid is somewhere around here at the age of 30. So this is shows you the scatter plot for that. So that kind of concludes our task 2, where we generate visualization to illustrate some of the key insights. Next task is to identify and interpret patterns or anomalies. So what we're going to do is we can use the visualizations and summary statistics to identify these patterns that we looked at and look for anomalies such as unusually high fares or missing data trends. Some of the example observations that I can mention based on our plots is higher class passengers have higher survival rate. We saw that in the first plot graph. And older passengers paid higher fares. That's what we saw in our scatter plot, where the concentration of older people had more higher paid fares. Our task 4 is to summarize findings in a report. Now, the things that we'll do here is we'll create a report summarizing insights, including key visualization and statistical summaries, and you can upload these different plots that we did to that. Some of the plotting looks like, if you want to create a document, it looks something like this, where I can say Titanic data set EDA report. This is how you'll create a report if you're a data scientist. I'm going to get rid of that. And here I'm going to say one overview section. I'll create an overview section where I can say data set contains around 891, I think, rows and 12 columns. Next, I can specify that missing values handled for, we did for age. And what did we do for that? We filled with median. That's what we did. And we also did something for embarked, and that was we filled that with mode. So I can say filled with mode, something like that. Next, you can give, so I can skip this, that's basic overview. Next, I can say key insights. Make sure I don't type it wrong. Next, I can say survival rates are highest for first class passengers. It's around, I think, 62% based on the plots that we have seen, and lowest for, we had first and second class and third class customers, but it was lowest for third class customers, which is around 24%. So you can display those, kind of attach those graphs that we have created here, the plot that we have created, and I can say majority of passengers are aged between, we checked the age distribution, it was between 20 to 40 years and mostly between 25 to 30 years. So you can specify that and display your plot here, which you can include the screenshots. And a positive correlation exists between fare and survival, because we saw that older people paid more amount, which means they have higher survival rate because they were in the first class category, whereas the younger people who paid less fare had less chances of survival because they were in third class. And then finally, a third ones which we did was visual insights. So based on whatever we did above, so what we can do is you can include the screenshots of those plots right over here. So this is how a EDA report looks like, and this is what is expected as a delivery. You have the clean data set with missing values handled and duplicates removed, a set of visualization showcasing trends, comparisons and relationships, and a written summary of key findings, patterns, and potential hypotheses. That's what we give. Now, for additional practice, what you can do is you can use another data set and apply the same EDA steps. You can explore advanced visualizations like box plots or pair plots in Seaborn, and you can create a dashboard for your findings using Plotty or Dash, which are other tools that are also available. So, to summarize, our last day of week 2, we applied our pandas knowledge and visualization skill to perform a full EDA project, uh, culminating in a report that highlights our ability to manipulate, analyze, and visualize data effectively. This is very helpful in the world of data science to provide reports to data scientists and to business managers, which can make decisions accordingly based on the reports that you specify. So I hope you were able to follow along. If you have any questions or problems or issues, let me know and I'll get back to you.